family one for his first Halloween. I made him an astronaut. And then my husband and I were like, what was I? I think I made him Jupiter. And I was like the Milky Way galaxy or something. Or the sun. I was the sun. That's what it was. That was cute. Oh. And he was still in a stroller, and I changed his stroller to a rocket ship. Oh my gosh. All right, so anywho, 2-4 angle pairs. So a little bit of vocab to start off with. We're going to start with our new friend, complementary angles. There we go. Complementary angles. Anybody know what these are before I tell you? Complementary. Carson? Yes, you got it. 2 angles whose sum is 90 degrees. That's it. That's the only requirement. Their sum has to be 90. They don't have to be adjacent to each other. They can be, but they don't have to be. So you could have complementary angles that look something like this. If I have a known 90-degree angle, and then let's just say I split that angle up into 2, it doesn't even, they don't have to be equal. So just say I have angle 1 and 2. I have no idea what their measure is. I don't know what angle 1 is. I don't know what angle 2 is, but I know that together they have to add to be 90, right? So I could say angle 1 and angle 2 are complementary without even knowing what their measure is. I have no idea. Maybe it's 60-30. Maybe it's 45-45. I have no idea. Maybe it's 80-10. I don't know. But again, they do not have to be adjacent. So I could literally have 2 other angles that, let's say I have an angle 3 here, and maybe I have an angle 4 here. Oh wait, that one's way too big. Angle 4 here. And if I happen to know somehow, let's say this one really is 60 degrees and this one really is 30 degrees. Now I know that their measures have a sum of 90, so I could say that angles 3 and 4 are also complementary. That is the only thing that is required to have a sum of 90. Can be adjacent, doesn't have to be adjacent. And then I do the same thing for supplementary. And those are the same exact thing, except they, Carson? You got it. These ones add up to be 180 instead. 2 angles whose, oh, thank you. And again, that is the only requirement. They do not have to be adjacent. They can be adjacent, but they certainly don't have to be. What's nice is that 180 degrees is simply a straight line. So if you have any 2 angles that together make a straight line, like angles 1 and 2, you know for a fact that they are going to be supplementary. So again, without knowing the measure, I have no idea what their degrees actually are, but I know that their measures would have to add to be 180. Maybe angle 1 is 100 and 2 is 80. I don't know. I have no idea what they are, but I know that together their sum is 180. So angle 1 and angle 2 are supplementary. And again, they do not have to be adjacent, so I'll just draw a pair that are separate. So here's an angle 3, and then maybe here's an angle 4. And as long as I know their measures, let's make you oh, I don't know, you could be 20 degrees and you could be 160 degrees. Ah. That's enough to tell me that angles 2, I'm sorry, 3 and 4 are also supplementary. Okay, so before we go on to the other vocab, we're going to make a little chart. So I'm going to give you an angle measure. We are going to list that angle measure's complement and then its supplement. And a nice little chart. So I'm going to give you the original angles and you see if you can fill out the rest of the chart. Okay, there are your angle measures. Take a moment and see if you can determine the complement and supplement for each. You guys are always welcome to use a calculator. You don't even need to ask. Okay, we have some. Let's see how far we got. So we'll start off with the easy one, 17. If I have a 17-degree angle, Riley, go ahead. What's the complement? Yes, 73 degrees would be our complement. And what would the supplement have to be? Carson, go ahead.
163 degrees.
163 degrees is correct. Okay, now we move on to another one. It's got a decimal, no big deal. Totally doable. Liam, complement of 61.4. 28.6 is correct. And for the supplement, Patrick, I agree with you, 118.6. Thank you so much. Okay, the next one we gotta, oh, actually we hit a snag on the next one. So here's the thing. If you already have an angle that's bigger than 90, how do you have a complement? Do you go negative angles? No, we don't. You're not gonna touch negative angles until trig, honestly. So we just say that it doesn't have a complement. It's already bigger than 90. So not applicable. I'm just gonna put a dash. It doesn't have a complement. It's too big. But it certainly has a supplement. What would its supplement have to be? Riley, go ahead. 77.25. Sure, if you left it as 1/4, that's fine. So the same thing happens for 135. It's too big to have a complement. So its supplement would just be Taylor. You got it. What if the angle is X? How would you write its complement, Ava?
90 minus X.
You got it. 90 minus X. And so for the supplement, it would just be, Riley? Yes. So no matter what the angle is, you can always find its complement and supplement by doing 90 minus or 180 minus respectively. So I'm going to apply that same thing for this 2y minus 15. It just looks a little crazy at first, but it's okay. I still apply the same rules. So when I go to do the complement, I hope this is what you did. I hope you said, well, here I did 90 minus whatever the angle is. I'm going to do that again. I'm going to do 90 minus whatever the angle is. The angle just happens to be all of that. Zoom in a little bit if you can see. Whoa, whoa, whoa. I have it. There we go. So now all I have to do is simplify this. So I hope you did 90 minus 2y plus 15. That's what I hope you did. And then when you put it all together, isn't that just 105 minus 2y? So that would be the complement. You do the same thing for the supplement. Anybody think they have the supplement correct? Aiden, go ahead. You got it. So I'm doing the same thing. I'm going to do 180 minus whatever the angle is, which in this case is 2y minus 15. And then I just do the same steps. Oh, sorry. I just go ahead and just simplify this. So 180 minus the 2y plus 15. So that's where 195 minus 2y comes from. Degrees. Does that make sense? That's all right? Everybody's okay? All right, we're going to try a little word problem, see how that goes. So here's your word problem. I get it so we can see it. The supplement of an angle is 3 more than 4 times its complement. What is the measure of the angle? Give this one a whirl. If anybody thinks they have an answer, when you get it, tell me. Liam, what's your answer?
Oh, no, no, no. Wait, 59. I got.
You're super close. I do not have 59 though. So I'm interested, does anybody else have an answer? Dominic?
60.
60? 60?
Yeah.
That is not what I got either, but it's still pretty close. Taylor?
I got 61.
I got 61 as well. So let's investigate. So the problem says the supplement of an angle is 3 more than 4 times its complement. What's the measure of the angle? Do you know what the measure of the angle is? No, I'm going to call it X. I have no idea what the measure of this angle is. I'm going to call that X. There's other ways to do this problem. You could have called the complement X or the supplement X. I think it's easier to, let me call the thing that I'm looking for X. Because when I solve for it, then I'll know I have my answer. So I'm going to say let X equal the measure of the angle. And now that I have assigned my variable, I'm literally going to take the question and turn it into math. The supplement of an angle. If my angle is X, what is the, what am I saying? If my angle is X, what's the supplement? 180 minus X. So the supplement of an angle, my angle, there it is, 180 minus X, is, what's is mean in math? Equals 3 more than, what's that mean? Yeah, I'm gonna add 3. You can either do it at the end or the beginning, it doesn't really matter. 3 more than 4 times its complement. So I know I need to do 4 times whatever the complement is. So 4 times, what's the complement? Yes. That would be a correct equation. So you could either have the 3 over here, or if you have the plus 3 at the end, that's fine. This is not the only correct equation, but it's the easiest one in my opinion, because I'm literally just changing their words into math as I go. And I don't have to think about it. I just, well, I mean, there's a little bit of thought, but I don't have to worry about, I'm just going beep, bop, 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 bop. As I read, change, 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 change. Now I have an equation. Let's solve it. So let me move this up a little bit. 180 minus X. I'm going to have to distribute that 4. So it's at 360 minus 4X. Combine some like terms. Okay, I'll add the 4X minus the 180. I have 3 X's. Was it 183? And then divide by 3, looks like I get 61. It never hurts to check yourself when you do a word problem, right? So let's see, if my angle is 61, that means its complement would have been 29. And the supplement would have been 119. Is that right? Supplement. So again, this is my answer, but let's just see if it's true. Is the supplement 3 more than 4 times the complement? Okay, let's take 29. Oops. 29 times 4. And if I add 3 to it, what do you know? I get 119. Yes. So my angle was 61. Does that make sense? Okay. We have talked about vertical angles, but now we're finally going to make it official. And I swear, vertical angles are probably going to be like your favorite thing in the whole course because they're so easy and they give you so much. So vertical angles, here's what they have to do. They have to share a vertex. And have sides that form opposite rays. This is one of those definitions that it's so much easier to get in a picture than it is in words. So these are the ones, you literally have 2 lines that cross. And the ones that are directly across from each other, those are the ones that we refer to as vertical angles. So we talked about these last week because we used them in a proof. And we got to use them. Remember how we proved that the ones right across from each other were equal? So we already proved that that is true, but now we get to use it for everything. So every time you have this, when you have ones that are right across from each other like this, they're called vertical angles and their measure is always equal. So we'll put a big star and say, this is actually called the vertical angle theorem. Vertical angles are always congruent. So that is it for 2-4. And then I would like to just go right on to 2-5 because it's literally 3 lines and we're done. Okay, so sorry. But we got a busy week. So I gotta flip the page. Oh my gosh, I'm out of pages. Don't fret, I have a whole other notebook. My old one. I treated myself to a new one this year. But this one still works just fine. Here we go. So 2-5 is just on perpendicular lines. Do you remember what perpendicular lines are? What do they do? Yes, I'm seeing people doing it. They're the ones that meet at exactly 90-degree angles. So these are 2 lines that intersect to form 90-degree angles. We have a symbol for perpendicular. Thank goodness, because who wants to write that word so many times? Anybody know what the symbol is before I tell you? Isabella. Yes, it's an upside down capital T. So it looks just like that. That is our symbol for perpendicular. So you will see that symbol all over the place. Because it's a really big word and no one likes to write it all out. Okay, So we have two theorems related to this, and then we're done. So first one. If two lines are perpendicular, then they form congruent adjacent angles. So let's say you were doing a proof and part of the given information was that two lines were perpendicular to each other. So I can now use this to say, all right, cool. Well, if I know I have perpendicular lines, that means that the two angles that are formed have to be congruent to each other. And then our second one is basically just the converse. And by the way, not every theorem has a nice name, like, you know, Pythagorean theorem. That has a nice name, right? This doesn't really have a name, so you would actually just kind of write that. Sorry. Don't get hung up on like memorizing this stuff though. I promise. It comes, the more you practice with it, it all just sort of falls into place. Okay, so the next one, basically the converse of this. So we say, if two intersecting lines form congruent adjacent angles, then the lines are perpendicular. There we go. That is kind of interesting to think about. If you have two lines and they really are going to cross, but they're going to cross in such a way that the adjacent angles are congruent, the only way that that can happen is if those two lines are perpendicular, right? Because if you just have two lines that are just going to cross, let me just show you real quick. Here's just two random lines that cross. Their adjacent angles, which are the ones right next door, remember the next door neighbors? These are not congruent to each other, right? That one's a big old obtuse angle and this one's a little acute angle. So these do not apply here, right? These are not showing me that I have congruent adjacent angles. The only way I can get that is if it looks like this, right? Now these adjacent angles are congruent to each other. The only way that can happen is if those lines are perpendicular. Oh, how cool. Gosh. You see that? All this cool stuff. Who knew? But that's it for 2-5. See, I told you it was short. Okay, so I'm going to give you your homework. You are more than welcome to get started on it now. In fact, I would encourage you to do so. So let's see here. We are going to do page 53 to 54, numbers 26 to I'm going to put what it is. Yeah, okay. 34. And then page 59 to 60. 14 to 25. Yes, I have my fancy new bathroom pass. and You could just sign out on that sheet right there. See there? Oh, it's broken? Yeah. We got it. Okay. Alrighty. Have to pass still. Thank you. This one just made them for me. I'm so happy. We gotta fix this. Okay, your notes are posted, so you need those. Yes, here's my fancy pen. So if you would sign out right there, I guess my pencil's broken. On the, nope, to the left, by the door, left, left, left. Yeah, right there. Okay, it is live on Jupiter, ready for you. Whenever you are ready for it.
everybody. Have a great rest of your day. You too, bye. See you. Yes. Oh, yeah, I'll do it right now. Diagnostic quiz. It was just 1 point, right?
Yeah.
Okay. Ooh, that makes a big difference for you. Right? Because now it's a 90.
Thank you.
All set. See ya.